Hi, this is Denise, Elektor Community Manager.
Hello, I'm Arthur from Elektor.
Hello, I'm Ratchet from Elektor.
Hi, welcome. This is Clemens at Embedded World 2020.
We are at Embedded World 2020 in Nuremberg. Let's take a look inside.
Hi, this is Clemens at Embedded World 2020. Here I'm standing at the Congatec booth together with Zeljko, who is a marketing engineer at Congatec and who will introduce and present us the latest products. So Zeljko, what can you present us and how are you doing?
Hi Clemens, I'm very happy to have you here.
Thank you.
As I was born and grown up with Elektor magazine, and I'm happy to see you again in the industry. It gives me a good feeling to bring the makers to the industrial professional area. And Congatec is a pure player, pure focused on computer on modules. And here we have an example of what Congatec is doing. So we are focused on computer on modules. So here we have a starter kit for your lab. You see a computer on module, and here you can see the defined pins, and you connect this compact board on a carrier board, and customers can focus on the carrier board design, how they want to do it, because this is much easier than designing the complex processor module. So they can focus on their end application and use a professional computer module from Congatec. So this is what we are doing. We are doing the heart in the application of the customer.
So Congatec makes computer design easy.
Exactly, yeah. We simplify it, and that's why we like to have these starter kits where you can use them in the labs. So you just open it up and you build it up, and in minutes and some tests you can build up a close MVP, minimal viable prototype product for your real application.
And so this particular kit, I see it has a camera and...
Exactly. So here we are showing how easy, with our partner Basler, how easy to implement vision, to make a vision application, how easy to implement the camera with a MIPI or USB interface. And but to make it more interesting, we built up a demonstration here, as you can see. So a real application. Let's think about shopping, retail, how easy it will be in the future to shop. We built up here, as you can see, a basket. You can see the details of this kit here, this hardware setup, and you can see the monitoring display at the front desk in a shopping, for example. And in future, the shopping will be much easier. You just grab what you want in your basket, you buy it and you put it in the box inside, and you can see here on the display that these objects were realized, and without calculating, immediately you can see the price of the objects, of the articles that you are buying. You see the end price, what you have to pay, and in future you will do easy, quick paying. To see how easy it is with a hardware setup to build an application in a quick time with our partner Basler, which is an expert in vision and cameras. Their partner Irida Labs, who were doing the deep learning algorithm in the background, and we were preparing this demo. The objects, day by day, they were possible and able to implement a new object, a new article, to make this real and live in the close future.
Yeah, the numbers I see on the display. This is how sure he is about it, I think, and that's not the price.
No, so here it's the object recognition, how sure he is that this is an orange or that this is a bottle. Exactly, so this is not the price, this is the assurance, how sure he is about realizing the right object. And here on the right side you can see the component price list. And you just start with a starter kit.
So I take out the bottle,
Exactly, so you can see.
place it back in the basket.
Place it back and you realize you found one new bottle from Heineken, one item, and the price is here.
Yes, it's a bit disturbing to see that an orange is as expensive as a beer, but
Yeah, so you see how easy we simplify embedded hardware in a kit, show it in demonstration, and to simplify it for the customer, but still having complex technology in the background, bringing it together from hardware, software, and vision cameras.
so Congatec makes compute modules. Here is one. Can you say something more about it?
So this is our low-performance computer module based on ARM technology, based on a NXP i.MX8 processor from NXP, a multi-core processor with a very low power consumption. And this makes it possible to show it in a passive way with passive cooling.
Okay. Okay. Yeah, this is the heat spreader. Yes.
Exactly. This is the heat spreader that you fix on the module, yeah.
Okay. And so this compute module, which you say is low performance, is powerful enough to do this kind of applications.
Exactly, yeah. Even that it is around 2 to 3 watt TDP, it's able with this multi-core performance to drive AI at the edge.
So here we are standing in front of some boards with modules on it. What is this?
Exactly, so this is the future. This will be the next 10 to 15 years of compute on modules. Compute on modules HPC, so high performance computing, bringing this on a module form factor. So again, the same example. Congatec is focusing on these compute on modules, and we make it easier for the customer, bringing it on a carrier plate, and the customer is focusing on the carrier plate design for his application and can use the complex computer model design from Congatec. So this is the new upcoming form factor for the highest performance level of computer on modules. Congatec is a pure player and driver for computer modules since the beginning, and together with competitors we are defining this new specification and this new standard at the PICMG in US. We have weekly calls building out the pin out to show how the connector signals we are focusing should be, defining the pin out for the next generation of applications. And here we have two classes in this form factor, computer model form factor. We have the server class for edge server, and the smaller computer models for client applications. And you can see that this is going up to PCI Express Gen 5 generation, up to 25 gigabit Ethernet, and up to 49 PCI Express lanes. So we are talking really about here high performance computing on a module form factor. So this is a new form factor that we are focusing, and this will drive the embedded applications for the next 15 years.
Okay, so the form factors are the size A, B, C, D and E.
Exactly, yeah. Mm-hmm.
These are not just the sketchboards, these are the real sizes.
So these are the real sizes, and you see the most important components, so the processors, positioning, and how the RAM can be connected. So on the server versions you have the bigger RAMs, here you have the smaller ones, and as well as one of the most important components you can see here, the connector, which is really for high speed.
So this position is defined by the standards?
Exactly, yeah. Mm-hmm. So together with our competitors, we are defining these standards and we were defining the feature set. And this is very important for open standards, that customers can choose their heart, who is doing the most important component in their design.
And why are these new form factors not the same as the existing form factors, like the ATX factors and things like that?
They are made for the new upcoming interfaces. So we need solutions for the new upcoming interfaces, like the 5th generation of PCI Express, USB 4. And for these interfaces, the existing computer modules, connectors, are not certified for this high signal frequency that needs to be transported, connected. So that's one reason. The other reason is that computing performance at the edge will grow, and a lot of data need to be transported, checked. So with these new connectors, there are much more features and signals than on the former connectors.
So more pins to connect and faster signals. And so I think people would like to know, what kind of computing power are we talking about here?
So this is high performance Xeon processors, for example. So not just low performance server processors, even high performance server processors, Xeon processors, are now able to be implemented, to be cooled, and to prepare enough power for these components, for these processors.
Sounds very interesting. I wonder when I will have one on my desk.
So next year, when you come to Embedded World, you will see the real products and first real applications.
Because there are companies already designing, pre-designing test boards like these.
Right now, there is no existing product on the market, but the specification will be finished mid of this year. Okay. And I expect at Electronica trade show in Munich, there will be first products visible in the market.
Zeljko, thank you very much.
Thanks to you.
I wish you good luck with all the high performance computing power and the low performance and the artificial intelligence and whatever you hear here on the Congatec.
Always a pleasure to have you here.
Well, I have a wonderful electronic invention I want you to see.
It looks something like this.